A reference angle for an angle theta is the positive acute angle made by the terminal side of angle theta and the x-axis. A lot of words there, but what I want you to remember is it's acute and it touches the x-axis. Okay, we have to have those two things. So you want to remember it's going to be an acute angle that touches the x-axis. There are going to be a number of you that mess that up and don't make it touch the x-axis. That's not going to work. Okay, it has to touch the x-axis. So if you look at this first picture, picture 1, you should see that angle theta takes us into the second quadrant. Okay, the blue part, the angle theta takes us into the second quadrant. Well, the reference angle is the acute angle that touches the x-axis. So what we're really going to deal with is this acute angle touching the x-axis right here. That's going to be the reference angle. That's what we're going to deal with. This reference angle is going to allow us to deal with smaller numbers. Okay. If you look at picture 2 here, it looks like angle theta takes us to quadrant 3, right? But really what we're going to look at, the reference angle, is the acute angle that our angle makes with the x-axis. It has to be the x-axis. So right there, that's our reference angle. Really important concept. Okay, this is a really important concept for the entire semester. If we look at picture 3, it looks like they're taking us, the angle is taking us to quadrant 4. But the reference angle is the acute angle made with the x-axis. So right there, that is your reference angle. Example 4a says find the reference angle for an angle of 218 degrees. So what we're going to want to do is draw like an XY axis. Okay? So you don't have one as nice as this, I know, but you can draw one by hand. But draw an XY axis, and we're going to put that angle there, and we want to know what quadrant it's in, basically. So it helps to know the quadrantal angles. There's 0 and 90 and 180 and 270. We always need to know those. But look at where 218 is going to take us. 218 is going to take us around somewhere past 180 and before you get to 270. So I'm just going to kind of eyeball that up and say that's 218 degrees. Takes us to the third quadrant, right? Third quadrant. But if I find the reference angle, the reference angle is the acute angle that is made with the x-axis. This right here is the reference. Okay? That's the reference angle. And so I won't have to work with 218. I'll have to work with an acute angle, a number less than 90. And so what I want you to get to do is, I want you to do this in your head. I want you to be able to find the reference angle in your head. It's not that hard because what we're doing, I think I heard it, is we're saying how far past the x-axis are we? How far away from that x-axis are we? Does anybody know? 38. Can you see that? Now, mathematically, what we would do is 218 minus 180, I guess, is 38. But I wouldn't get hung up in that mathematical statement, okay? I would rather you do it in your head and just say, how far away from the x-axis are we? Well, we're a little bit past the 180. We're 38 past 180. Do that in your brain. It'll be faster, okay? So that answer is 38 degrees. So I want to do another quick example or two of that. So let's say 170 degrees. So out in the margin, somewhere out to the side, you've got some room. Just draw a quick little picture of 170. So here's 0, 90, here's 180, 270. I would know that 170 takes me about right to there. Okay? The question becomes, how far away from the x-axis are we? That's your reference angle. So do that in your head. What is it?
10 degrees.
10 degrees. That's the reference angle. Okay? That's it. And so what ends up happening is something like this. If I did sine 170 and sine 10, I notice that it's the same thing. Okay? It's going to be the same thing. And so I would rather work with 10 degrees than with 170 just because it's smaller. So let's try 280 degrees real quick. So same thing, I always start with the quadrantal angles, just so I can kind of identify the quadrant where 280 puts okay? So which quadrant are we going to end up in? Fourth quadrant, right? We're just past 270. 280 degrees is going to put us in the fourth quadrant. Okay? Now, sometimes people will mess up and do this. That's not the reference angle, because that's not an angle made with the x-axis. Be careful. I'm making an angle with the x-axis. So it's always, the question is always, how far away from that x-axis am I? Okay? So maybe we need to think about going all the way around is 360 degrees. Your question becomes, how far away is 280 from 360? That's 80 degrees. Okay? That's 80 degrees. So, mathematically, maybe you're doing 360 minus 280. I don't know if I'd get hung up on that kind of thing. I think it's going to be easier for you to just say, how far away from the x-axis am I? I'm 80 degrees before I get to 360. So then let's go back here to example 4b. Find the reference angle for an angle of 1387 degrees. Okay, well, that's tough because I don't know where that is. Okay, it's very difficult for me to pinpoint what quadrant that's in. And so let's go back a couple of sections to where we found the least positive coterminal angle. You might remember how we did that? We subtracted 360 a few times, so 1387 minus 360. Minus 360. Minus 360. Okay. So 1387 is going to put us in the same position as 307. Okay? I'm not saying that 1387 equals 307. I'm saying they're coterminal. That means they end up in the same spot. Okay? Can anybody tell me what quadrant 307 would put us in? That's the fourth quadrant, right? Somewhere in between 270 and 360, right? So 307, and it doesn't have to be perfect, it just needs to show the fourth quadrant. 307 would put us there, and so therefore would 1387. 1387 is in that exact same location. I need to talk about this reference angle being the acute angle formed with the x-axis. And so the question becomes, how far from 360 are we? Anybody do that in your head? 53. 53. That's it. The reference angle will be 53. Okay?